This problem will be a little bit more challenging. It's from the Harvard MIT Math Tournament in 1999, and I would like to focus on problem number 6. Is asking you to reduce the number, which is a little bit complicated, the cube root of an expression involving a square root. This expression involving cube roots, so the first instinct is to take the cube of the expression to get rid of the roots. And to do this, I'm going to rewrite these two terms into a and b to make the handwriting easier. So to take the cube of this, so we will use the binomial theorem. We know that a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. So using this formula, this becomes, so if we take the cube of this whole thing, this becomes the first term cube, so just removing a cube root, so this will be 2 plus square root 5. Second term is 3a squared b. I'm going to keep this for the moment. Similarly for the third term, 3ab squared plus b cubed, so just again removing the cube root, this becomes 2 minus square root 5. We can see that the square root 5 cancels out, so we have 4 plus 3a squared b plus 3ab squared. Let's see what's special about these two terms. So first one, a squared b, that will be the cube root of 2 plus square root 5 squared. I'm going to write this out, so just 2 copies of that, times b, which is the cube root of 2 minus square root 5. Well, they're all under the cube root, so I can combine them again, but I will combine it in a way that will make the calculation simpler. I will leave the first term and just look at the last two terms. This is 2 plus square root 5, 2 minus square root 5. So difference of squares formula comes in. So this is just a plus b times a minus b equals a squared minus b squared. So that's 2 squared minus square root 5 squared, which is actually 4 minus 5, so that's negative 1. What is the cube root of negative 1? It's minus 1. So this whole term becomes minus the cube root of 2 plus square root 5. What about ab squared? Similarly, just to write this out, a times b squared. And of course, now you know the trick. So I'm going to combine these two. Again, difference of 2 squares. So we have 4 minus 5, which is negative 1. Cube root of negative 1, that's minus the cube root of 2 minus square root 5. So we have the answers of those two terms. So this is 4 plus 3a squared b. Well, actually it should be minus, so just put minus the cube root of 2 plus square root of 5, oh I forgot the 3, the coefficient, plus 3, again the minus the cube root of 2 minus square root 5. I have a common factor of 3, so I'm just factor it out, including the minus sign. So what I have is cube root of 2 plus square root 5 plus cube root of 2 minus square root 5. Okay. However, this is exactly the same as the expression inside the bracket, the original expression. If I call this expression, the whole expression x, I have x cubed equals, I can remove this, 4 minus 3x. Or equivalently, I have x cubed minus 3x, sorry, plus 3x minus 4 equals 0. Okay, I have an equation, x cubed plus 3x minus 4 equals 0. Eyeballing it, we know that 1 is a root. 1 cubed plus 3 times 1 is 4 minus 4 is 0. So 1 is a root. That means x minus 1 is a factor. Okay, what's the remaining piece? Okay, we can just trial and error. That will be x plus x, sorry, x squared plus x plus 4. If you multiply this out, you get this back. So we managed to factorize this expression with x equals 1 being a root of this equation. And then the other two roots will be imaginary, because if you look at the determinant of this quadratic equation, it will be less than 0. So x equals 1, or the two imaginary roots. Okay. Well, what is x? Well, if you go back, x is actually this. And this is not imaginary. This is real. Which means that this expression is reduced to 1, which is very clever. The cube root of 2 plus square root 5 plus the cube root of 2 minus square root 5 is actually 1.